like to do this video about how to solve systems of linear inequalities. Again, if you've seen my other videos, then I'm going to start with this question here. Is 2, -1 a solution of this system? Well, what did I say that you're supposed to do when you have this type of question? You substitute. You substitute 2 in for x, -1 in for y, and see if it satisfies both of these inequalities. So I'm going to start with the first one, x plus y greater than or equal to 1. I want to see if 2, -1 satisfies this first one. So 2 plus -1, is that greater than or equal to 1? 2 plus -1 is 1. Is 1 greater than or equal to 1? Yes, it is. But I can't just automatically say yes because I have to see if it satisfies the second one as well. So then I have to substitute 2, -1 into that inequality. Okay, so does 2, -1 satisfy this inequality? 2 times 2 is 4, plus -3. Is that less than 2? 4 plus -3 is 1. Is 1 less than 2? Yes, it is. So it satisfies this one, and it satisfies this one. So the answer to this is yes. 2, -1 is a solution to this system of inequalities. One important thing to remember, when you have a system of linear inequalities, you have an infinite amount of answers that actually work. Now, we're going to solve, that's what this next thing says, graph the system of linear inequalities. It'll say solve the system of linear inequalities. So that's what we're going to do next. So we're going to solve these two systems of linear inequalities. Remember, when you have a system, you have two equations or inequalities that you're trying to find their solution. When you have a system of equations, you are looking for the point of intersection of the two lines. And here, with a system of linear inequalities, you're actually looking for the intersection of the shading of the two linear inequalities. Okay, so looking at this problem, I have y is greater than -4. I don't have an x here. That means my slope is 0. That tells me this is a horizontal line. This is a greater than. Remember, I can go through this again. If you have greater than or less than, then this is a dotted line. If you have greater than or equal to, less than or equal to, then this will be a solid line. And so this one's going to be a dotted line. And greater than -4, numbers to the right of -4 are greater than, so I'm going to shade to the right of that line. Then this line has a slope of 5 because it's in slope-intercept form. It has a y-intercept of 0. I'm going to have a solid line. And less than or equal to means I'm going to shade below that line. Okay, so let's graph the first one, the top one first. Y is greater than -4. Okay, y is greater than -4. I'm going to go to -4 on the y-axis. 1, 2, 3, 4. I'm going to draw a dotted horizontal line. Okay, I just missed that just a little bit, but that's okay. Greater than -4, I'm going to shade with color this time, hopefully it'll be faster, would be, oh, I have to the right. I don't know why I put right, that should be above that line. So I'm going to shade everything above this line. I'll be careful when I'm shading down here because it's not as easy to erase. a colored pencil. I like to use colored pencil when I'm doing a system of linear inequalities because then it's really easy to see where the shading intersects. And I don't know, I just think it's a lot easier to see the solution of a system of inequalities when you shade with two different colors of a colored pencil. You don't have to, because if you shade with a pencil, then you're just going to see where the darkest graphite, or I don't think it's graphite now, where the darkest pencil color is, gray. But with if you use colored pencils, I think it's easier to see, but you make your decision. It doesn't matter to me if you use colored pencils or not. Okay, so next I want to graph this bottom line. Y-intercept is 0, slope of 5. That means rise 5, 1, 2, 3, 4, 5, run 1 to the right. Or you could also go down 5, 1, 2, 3, 4, 5, run 1 to the left. It's equal to, so it's going to be a solid line. Trying to line that up. So a solid line. I didn't do too badly. Less than means I'm going to shade below that line. Above the line would be that direction. Below that line would be below that line. Okay, I'm going to shade. I'm going to turn my paper and shade. And notice the shading that I'm doing right now is actually red and blue intersecting. All the way down through here, red and blue is intersecting. I'll try to shade close to my line first. Try not to go over. That's where you have to color inside the lines. So all the way down through there. Oops, I went over a little bit. I might try to erase that. And look, that's not red and blue, so that's not part of the solution. This is red and blue, so that's part of the solution. Okay. Now, if I had to, let me see if my pencil can erase that a little bit. If I had to describe where the solution is for this system, then it would be in this region here. Any ordered pair that you would choose, let me make it red and blue, a little darker red and a little darker blue. Any ordered pair in this region would satisfy, I wonder where the blue went. I don't know where, oh, there it is. Would satisfy that system of inequalities. So in this region here, like I said, here down to here, any ordered pair in that region would work. Let's graph the second one. Now notice, I don't have a horizontal or a vertical line for the next part. So I've got to put both of them in slope-intercept form. The top one I'm going to subtract 3x. So I'm going to have 2y is less than negative 3x plus 4. I'm going to divide by 2. I'm going to have y is less than, I divided by positive so I don't flip my inequality, negative 3/2 x plus 2. So for that one, my slope is negative 3/2. My y-intercept is 2. I'm going to have a dotted line. It's less than, so I'm going to shade below the line. This one here, the only thing I have to do is add 2. So y is going to be greater than or equal to negative 3x plus 2. So for this one, I have a slope of negative 3, a y-intercept of 2. I'm going to have a solid line, and I'm going to shade above that solid line because it's greater than. Okay, so let's graph our lines first, and I'll shade as I go along. Y-intercept of 2, 1, 2. slope of -3/2. Rise 3, run 2 to the left. Rise 1, 2, 3, run 2 to the left. Rise 1, 2, 3, run 2 to the left. Or go down 3, 2 to the right. Go down 3, 2 to the right. I put all these dots because it's easier for me to make a straight line with all these dots. 1, 2, 3, 1, 2. Okay, get my straight edge. And I'm going to have a dotted line. I think I'm just going to draw my dotted line. Forgive me if it's crooked. One good thing about a dotted line, you can just kind of dot your way through it. There we go. And I'm going to shade below. I'll use red. I'm going to shade below this line. I'll do down here first. It's okay if you go out of the lines down here, but you want to try to stay as close to in the lines as you can when you're doing close to the line like that. You don't really want to go over. Okay, so there's that inequality shaded. Let's graph the next one. Okay, we're going to graph a y-intercept of 2 again, a slope of -3, so that means up 3, 1, 2, 3, right 1, 1, 2, 3, right 1, 1, 2, 3, oh, I went left 1, oops, up 3, left 1, up 3, left 1, sorry, down 3, right 1, down 3, right 1, down 3, right 1. Okay, straight edge. This time I have a solid line, so I might want to make sure to try to use a straight edge just so that I can make my line straight. Whoa. Up 3, left 1, up 3, left 1. 1, 2, 3, right 1, 1, 2. Doesn't seem to be lining up. Or is it just me? I think it's just me. Just a little off. Look, even with this straight edge, I was just a little off. Let me see if I can get that a little better. Yeah, forgive that first mistake. I'll try to erase a little bit, but you know. Erase my shading too. Line that up. Oh well, good enough. Okay, and now shading is above. So to me, above that line would be in this direction. So above my solid line, I'll try to follow my solid line all the way down. And look, I haven't intersected with the red yet. No red intersection yet. But look, I'm about to. There, it starts to intersect. There, all the way down through here. So it's really just a small piece of intersection. Just this area right here is the point of intersection. So I'll go make it redder also. The word redder. I'll go darken the red. So here is my intersection. I'll darken the blue again too. In this area right here. That's my point of intersection. Okay, I'll go on to part 2 of this video in the next one. I will continue right now, but I'll split it up when I get ready to download it. So there's just solving by graphing. That's my solution here in this region, and then here's the solution here in this region. In the next part, we're going to actually